Today we're going to be moving on to our next chapter, which is going to be trigonometry. We're going to be talking a lot about the trigonometric ratios, and we're going to be solving for sides and angles utilizing those ratios. So what is trigonometry? Trigonometry is just the study of triangle measurement. And we use trigonometric ratios when we have a right triangle. So looking here at triangle ABC, this is a right triangle because angle C has this little box here telling me that it's 90 degrees. And then my sides in a right triangle, the side opposite of that right triangle is always going to be my hypotenuse. The other two sides, A and B, the sides that make up that right angle, are going to be what's called my legs. So when we're looking at trigonometric ratios, each acute angle of a right triangle, so we have two acute triangles, acute angles, A and B, they're going to have the following trigonometric ratios. So we're going to first look at sine. Sine is the ratio of the leg opposite the angle to the hypotenuse. So if we're looking at sine of angle A, we're going to be focusing on this angle here, angle A, and we need to create the ratio of the leg opposite the angle. So it's going to either be A or B, and it needs to be opposite the angle. So across from this angle is going to be side A. So that's going to go on the top of my ratio. And then the hypotenuse, always the side opposite my right angle, so it's going to be A over C is the ratio. If I'm looking at side of angle B, we're then going to be looking at this angle here, and we're going to create that same ratio, the ratio of the leg opposite the angle. So opposite this angle is going to be side B here. So that's going to go on top of my ratio. And then my hypotenuse, again, is staying the same. It's going to be C. So that ratio is going to be B over C. So you need to make sure you're paying attention to which angle they are referencing, because the ratios are not going to be the same depending on their angle. Now we're going to look at cosine. Cosine is the ratio of the leg adjacent to the angle. Adjacent means next to or touching. And then it's the ratio of the leg adjacent to the angle to the hypotenuse. So if we're looking at cosine of angle A, I need the ratio of the leg adjacent to the angle. So if I'm looking at angle A, my leg that is adjacent is going to be B. And that's going to go over my hypotenuse, which again is going to be C. So B over C. If I'm looking at the cosine of angle B, so I'm looking at this angle here, I need the ratio of the leg adjacent to the angle. So A is going to be the leg that is touching angle B over top of my hypotenuse again, which is going to be C, always across from my right angle. And then lastly, we're going to look at tangent. Tangent is going to be the only trigonometric ratio that doesn't involve your hypotenuse. So it's only going to be your legs, and it's going to be the ratio of the leg opposite the angle to the leg adjacent to the angle. So opposite over adjacent. So looking at angle A, we're right here, I need the leg opposite of it, which is going to be A, over the leg adjacent to it, which will be B. B is making up angle A. So A over B. If I switch it around and find the tangent of angle B, I'm going to be looking here. So I need the ratio of the leg opposite the angle. Leg opposite is going to be B over the leg that is adjacent to angle B. So the leg that's touching it is going to be A. So my ratio is going to be B over A. And you'll notice with tangent, they're going to be reciprocals. A over B, B over A. In order to remember our trigonometric ratios, we use what is called SOHCAHTOA. So it's going to be SOH, S-O-H. And what this stands for is sine, first letter is S, sine, equals O, which means opposite goes on top, and then H, hypotenuse, goes on the bottom. So sine opposite over hypotenuse. Ca is for cosine, C-A-H, and its C is cosine. The A stands for adjacent, and H again stands for hypotenuse. So cosine is adjacent over hypotenuse. And then our last one for tangent is going to be TOA, or T-O-A, and this stands for T, tangent, O, opposite, A, adjacent. So tangent is opposite over adjacent. So SOHCAHTOA. You're going to hear that quite a bit over these next few days. SOHCAHTOA. So for example 1, we need to give each trigonometric fraction in simplest form. So I am given triangle ABC, and I need to find my ratios. So first, looking at sine of angle A. So we're looking at angle A first. And sine, I know from is sine opposite over hypotenuse. So my ratio for this is going to be my opposite side, or leg. Opposite of A is going to be 5 over my hypotenuse. Hypotenuse is always across from your right angle, so I can already label this as hypotenuse. So over 13. 5 over 13 is the simplest form for that. We cannot divide both of those numbers by anything. Now we're going to look at cosine of angle A. So looking at the same angle here, but we are going to be doing cosine is adjacent over hypotenuse. So looking at this angle, my adjacent leg is going to be this one here, 12, because it's making up that angle, over my hypotenuse, which is going to be 13. And 12 over 13 cannot be simplified. And then lastly, I want my tangent of angle A, so that's going to be TOA. So we're going to do tangent is opposite over adjacent. So looking at angle A, I need my opposite. Across from it is going to be 5 over my adjacent leg, which will be 12. So I have 5/12, and again, that is in simplest form. Now we're going to switch and start looking at angle C. So we're going to start back over and figure out what sine of angle C is going to be. So looking at angle C, I need sine opposite over hypotenuse. So opposite of this angle is going to be 12. My hypotenuse never changes, so still 13. 12 over 13. Again, cannot simplify that. Then looking at cosine of angle C, so I need cosine is adjacent over hypotenuse. So looking here, my adjacent leg is going to be 5, BC, over my hypotenuse, does not change, still 13. And then lastly, I want to find the tangent of angle C. So tangent, opposite over adjacent. So looking at angle C, my opposite across from it is 12 over my adjacent side, which is going to be the leg touching it, which will be 5, 12 over 5. And again, cannot simplify that. That is already in its simplest form. Moving on to the second page, so now we are going to be finding side lengths using trig. And you need to make sure whatever calculator that you are using is in degree mode. There's also radians mode, so you need to make sure it is in degree mode because the angles we are looking at are in degrees. If you're unsure if your calculator is in the right mode, please reach out to me. If you don't have a calculator that can do trig functions, again, please reach out to me because I can set you up with an online calculator. Okay, so when we are solving for a missing side, we are given an angle, and we know this is a right triangle, so we can use our trig functions. We're given one angle and two sides. So first thing we need to do is we need to look at our reference angle. So we have this one here and figure out which sides are given to us in regards to this angle. So first I know that this side here that is 19 is going to be my hypotenuse. My hypotenuse is always across from the right angle. That's never going to change. And then I need to figure out if this side here that is x is either my opposite leg or my adjacent leg. So it is not touching this angle that's 28 degrees. So it's not going to be my adjacent leg. So this is going to be my opposite side. So I have my opposite and my hypotenuse. So I need to figure out which trig function involves opposite and hypotenuse. So I'm going to go through SOHCAHTOA. So starting with sine, opposite, hypotenuse. Perfect, right there. So we're going to use sine. And when we set this up, it's going to be sine of our angle, which is 28 degrees, equals our ratio opposite over hypotenuse. So opposite was x over my hypotenuse, which was 19. So I have sine 28 degrees equals x over 19. Now to solve for x, I am just going to do this algebraically. So to get 19 out of the denominator, I'm going to multiply both sides by it. Cancels on the right, and I need to do the same thing on the left. So I'm left with 19 times sine 28 degrees equals x. Now in order to figure out what x is, I'm just going to go straight to my calculator and plug 19 times sine 28 right into there. And you're going to get decimals, so I want you to give me one decimal place. So when I plug 19 times sine 28 degrees, I get x is equal to 8.9. So that means the length of this leg here, x, is 8.9 units. I'm going to also go over number 8 with you because the algebra on this one's going to be a little bit different. So again, we're going to start by looking at my angle that I'm given, which is 33 degrees, and figuring out what two sides I have. So for starters, across from my 90-degree angle, I have my hypotenuse, or x, always my hypotenuse, never changing. Then I need to figure out which leg this is, if it's either my adjacent or my opposite. So adjacent will be touching my angle, opposite is going to be across from it. So in this case, I have my opposite once again. So going through my sine functions, my sine cosine trig functions, this one I'm going to once again use sine like I did up here because I have my opposite and hypotenuse. So I'm going to set this up as sine of my angle, which is 33 degrees, equals the ratio opposite over hypotenuse. So 15 over x. Now we need to solve for x, but right now we have x in the denominator. So in order to get that out of the denominator and solve for it, we need to multiply by x. So those are going to cancel, and we're going to do the same thing on the left. So we'll be left with x times sine 33 degrees equals 15. Now x still is not by itself, so I need to take it one step further and get rid of this sine 33 degrees. So in order to do that, I'm going to divide on both sides by sine 33. Those cancel. Sine 33. So then x is going to equal 15 divided by sine 33 degrees. So I'm going to take this entire thing here and plug it into my calculator. 15 divided by sine 33 degrees. And when I plug that into my calculator, I get 27.5. So the length of my hypotenuse here is 27.5 units.